So we have talked about that when you're passing multiple signals, there can be correlation loss on those signals. We talked about a couple of techniques. One technique by consolidating the signals when it's possible, and that can avoid correlation loss. Or we can synchronize the signals using a synchronized enable, and that can also help avoid the correlation loss. But sometimes you actually need to synchronize each and every bit of the bus. And one specific case of that is FIFO pointers or counters. Okay, FIFO read and write pointers are counters. You need to send each of those signals across the clock domain boundary, and there are chances of correlation loss. So what do you do? So let's understand. Synchronize. How do you synchronize counters? And this is specifically used in case of FIFO pointers. So going back to basics, that when you're transferring data across clock domain C1 to C2, the transmitting side has two states, 0, 0 and 1, 1. But the receive side can have some invalid states or data. 0, 0, this is valid. But here 1, 0, not valid. 1, 1, valid. So this and this are valid, but this is invalid. Okay, so you can have invalid state or because of loss of correlation. Now, specifically for the case of counters, this can be avoided by, rather than using binary code for the counters, you use gray code. And how that avoids loss of correlation is, you typically in binary counters, when you're going from one number to a higher number, more than one bit can change. For example, here, when you go from this, which is 1 to 2, so you're going from 1 to 2, this bit is changing, and also this bit is changing. So there are multiple bits which are changing when counter increases. So binary encoding when count increases greater than 1 bit can change. If more than 1 bit can change, that means correlation loss, because 1 bit may be captured earlier, 1 bit may be captured later, and then can lead to unknown states. Like here, both the bits are changing at the same time, here and here, and that led to an invalid state. Unlike binary encoding, gray encoding, you only allow 1 bit to be changed. Just changing the encoding, as you, this is still a counter. Here, 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 for all the numbers in gray code, only 1 bit changes. And in FIFO, you only need to compare, so that's okay. So gray encoding allows only 1 bit to change, and because of that, correlation loss does not happen because only 1 bit is changing, and that is captured. So this is one of the ways to transfer when you cannot consolidate the signals and you still need to pass through all those signals through synchronizer. This is one of the ways.